Hello friends, our project is action and content based community detection in social networks. We did our project under our faculty Dr. Vasudev Verma and with the help of our mentor Mr. Prateek Mehta. So what was the motivation behind this project? Studies performed in the last few years on the social and natural networks revealed that the algorithms used for graph clustering are neither adept at nor useful for explaining partitioning patterns observed in those networks, such as the arising of communities, groups, or clubs. So those kind of structures are really interesting for both theoretical and practical reasons. So what would be the applications of this project? The topic analysis, improved recommendation system. So what was the problem while finding the communities in our project? So first of all, we describe a community. A community is a subgraph containing nodes which are more densely linked to each other than the rest of the graph. The problem is to work on the user matrices to build weighted graphs upon which algorithms for detecting natural structure can be applied to identify compact communities. So we were doing this project in 3 phases. In the first phase, we crawl the social networks and build user profiles and store interactions between them. We can use any social network, or if a dataset is available, we can use them directly. So in the phase 2, we find the communities in social network based on the features like actions like commenting, likes, retweets, as we see them generally in any social networking site. The content they share or follow in a social network can also be one of the features for finding the communities. In the phase 3, in the final phase, we have to visualize the communities and come up with a better evaluation techniques for the communities found in the phase 2. So first of all, in phase 1, what we did is crawl the Facebook data via their APIs, fetch the status, user description, groups, but due to the API limitations and restrictions on the request, this data was not fetched to build the base graph of the friendship network. We also work on the Twitter data set, but it has also the same limitations on APIs. So finally, we took up the FriendFit data because the data was structured with the base following follower graph and the rich textual and non-textual features. So in the phase 2, what was approach? The structuring FriendFit data, feature selection, community detection on FriendFit data. Structuring the data, removed non-English content from the dataset, selected only 60,000 users who posted and comment only in English for the easier text processing. We also changed the follower followed file corresponding to include only those users. We removed non-ASCII and non-English content from the entries and comments. The above data was also dumped in the database with the appropriate schema. So what were the features selected to find up the communities? So first of all, we look up for the services, then subscriptions, and the popular people followed, the likes and the comments. The weight of the edge of each feature between 2 users was calculated using Jaccard similarity method. In the phase 3, visualization techniques and feature extension was also employed. In the feature extension, the description of the user to come up with a similarity between 2 users, similarity calculating using bag of words technique. These kind of techniques were employed. We also use the comment and post text for the content based similarity between the users. Similarity calculating using the word2vec feature from the Gensing module. For visualization, we use the iGraph and the Gephi tools already available on the internet freely. So this is how our workflow in the project. We firstly select the data set and the pre-process it and the dump into the database, the feature selection and the visualization, and after all the evaluation. So what were the algorithms and measures we used in the project? First of all, for the similarity measures, we used Jaccard similarity, cosine similarity, word2vec and bag of words. Algorithm for the community detection was fast modularity optimization, which is also known as Louvain method, and Markov clustering. Best results were also given by the Louvain method. For the evaluation measures, we use the modularity, the community size, and the intercluster conductance. So different visualization for graph were constructed based on following features: likes, comments, content-based similarity of comments, and finally linear combination of all the above features with weights assigned accordingly was used to build the graph. This is the sample visualization based on the feature we discussed above. For likes, suppose there is a user A and B in the base graph we estimate the weight of edge using Jacquard similarity as number of likes of A on posts of B upon total number of likes by A. Similarly, for comment graph, the weights were calculated. And finally, for the content-based similarity, for user A and B, we had all comments of A and B. So if there was an edge between A and B in the base graph, we vectorize the comments using word2vec tool from GenSim module. Edge weight would be decided on the cosine similarity between comments provided by this. So what is modularity? Modularity is one of the measure of structure of network or graphs. It was designed to measure the strength of division of a network into modules, also called as groups, clusters, or communities. Networks with high modularity have dense connections between the nodes within the modules, but sparse connections between nodes in different modules. Apart from it, we also calculated the betweenness centrality. Betweenness centrality is an indicator of node centrality in a network. It is equal to the number of shortest path from all vertices to all others that pass through that node. And similarly, eigenvector similarity and centrality is a measure of influence of a node in the network. So here we can see how the different communities are coming up. So in a nutshell, we have explored the viability of various edge weighing methods for the purpose of community detection in a very large network. So in the future scope, we are discovering inherent community structure can help us to understand the networks more deeply and reveal the interesting properties shared by the members. People belonging to the same community are more likely to have common hobbies, social functions, occupation, interest on the some topics, viewpoints, etc. Therefore, the identified communities can be used in collaborative recommendation, information spreading, knowledge sharing, and other applications which can benefit us greatly.